Hey everyone, and a massive welcome to all you Class 10 CBSE students out there. Look, if you've been staring at Chapter 1 of your math textbook feeling, well, maybe a little overwhelmed, I want you to take a deep breath. You are in exactly the right place. In this explainer, we're going to completely demystify real numbers together. We're going to break the whole thing down, make it super logical, and get you absolutely ready to crush those board exams. Okay, let's dive into this. I actually want to kick things off with this really brilliant quote straight from the National Curriculum Framework. It says, "Unlike any other subject, the notion of truth in math is timeless and absolute." I mean, really think about that for a second. We aren't just memorizing a bunch of random formulas today. We're doing logical detective work to uncover absolute truths that literally can never be debated. We are going to build mathematical arguments so solid that they're going to be true for all of time. So here's our roadmap for today's explainer. First, the magic of real numbers. Second, the DNA of numbers. Third, mastering HCF and LCM. Fourth, proving the impossible. And finally, chapter summary and exam tips. Let's jump right in. Section 1, the magic of real numbers, building the foundation. All right, put on those mathematical detective hats because we need to clear up some very basic definitions before we get to the heavy lifting. Notice how neatly the mathematical universe is divided here. On one side, we have our rational numbers. These are the orderly ones, right? They can be written perfectly as a fraction, P over Q. But on the other side, we've got the rule breakers, irrational numbers. These absolutely cannot be written as neat little fractions. We're talking about numbers like the square root of 2, the square root of 3, and pi. I need you to keep this distinction locked in your mind because we're going to heavily rely on that later when we reach the climax of our explainer. Section 2, the DNA of numbers, the fundamental theorem of arithmetic. Okay, so before we start solving complex problems, we really need to understand what numbers are actually made of. Enter the prime numbers. Think of these as the atomic, indivisible building blocks, or what I personally love to call them, the DNA of the mathematical universe. And this brings us to the fundamental theorem of arithmetic. Listen up, because this is a massive board exam call-out, folks. This theorem states that every single composite number can be expressed or factorized as a product of primes. And here's the kicker. This factorization is completely unique, apart from the order in which those prime factors occur. So the absolute crucial point to remember is that no two composite numbers will ever share the exact same prime DNA. And this right here brilliantly illustrates the concept in action. Let's look at a pretty big number straight from your textbook, 32,760. Imagine drawing a factor tree, branching down, and pulling out prime numbers one by one. We pull out 3 2s, 2 3s, a 5, a 7, and a 13. So our final prime DNA is 2 cubed times 3 squared times 5 times 7 times 13. When written in ascending order, this specific combination of prime powers belongs only to 32,760. It's literally its unique mathematical fingerprint. Section 3, Mastering HCF and LCM, the Detective's Toolkit. So we've got our number DNA, but what do we actually do with it? Well, let's shift focus to practical application and give you the detective's toolkit you need to crack those exam questions. Let's clear up the confusion between highest common factor and lowest common multiple right now with a super handy memory trick. HCF stands for highest common factor, sure, but I want you to think of it as highly common. You only take the primes that they share, and you take the smallest power. LCM stands for lowest common multiple, but think of it as largest coverage. You need to cover every single prime involved across both numbers, taking the greatest power of each. Let's actually see this toolkit in action with a classic textbook example. We have the numbers 6 and 20. The DNA of 6 is 2 to the power of 1 times 3 to the power of 1. The DNA of 20 is 2 squared times 5 to the power of 1. Okay, for the HCF, highly common. What's shared? Only the prime 2. And the smallest power? That's 1. So our HCF is simply 2. Now for the LCM, largest coverage, we need all the primes, 2, 3, and 5. The highest powers are 2 squared, 3 to the 1, and 5 to the 1. Multiply those together, 4 times 3 times 5 equals 60. Boom, solved, just like that. Now prepare yourselves for a vital, and I mean vital, shortcut for the board exams. We call this the golden formula. For any two positive integers, let's call them A and B, the HCF multiplied by the LCM is exactly equal to the product of the two numbers themselves. Listen, if an exam question gives you the two numbers and the HCF, absolutely do not waste your time building prime factor trees again. Just plug your knowns right into this formula to instantly find that LCM. You might be wondering, why does this matter in the real world? Well, let's look at an awesome problem from the NCERT text. Sonia and Ravi are driving around a sports field. Sonia takes 18 minutes for one round, Ravi takes 12 minutes. If they start at the exact same time, when are they going to meet again at the starting line? Think about it. They are running in cycles, generating multiples of their times. To find the exact moment those cycles align perfectly, we need the lowest common multiple. The LCM of 18 and 12 is 36. So mathematically, we know for sure they will cross paths precisely at the 36-minute mark. This is mathematical modeling at work, guys.
Section 4. Proving the impossible. The climax.
All right, make sure your exam hacking hats are firmly strapped on because we have reached the climax of Chapter 1. Here is the million-dollar question. How do you logically prove that a number like the square root of 2 is irrational? You can't just sit there writing down decimals forever and say, look, it never repeats. That is definitely not absolute truth. We need a rigorous, bulletproof method. And the answer to that is a brilliantly clever technique called proof by contradiction. It's kind of like a police interrogation. You assume the suspect, in this case, the mathematical statement, is telling the truth. You say, okay, sure, let's pretend you are a perfectly normal rational fraction. Then you just follow the mathematical laws step by step. If their story leads to a mathematical impossibility, a contradiction, then you know for a fact their original claim was a lie. But before we interrogate the square root of 2, we need a secret weapon, Theorem 1.2. It states, let p be a prime number. If p divides a squared, then p also divides a. Just to put that into perspective, if the prime number 3 divides 81, which is 9 squared, right, then 3 absolutely must also divide 9. Keep this tool super handy. We are going to need it literally right now. Okay, massive board exam call out here. Follow this logic very closely. Nailing these steps is guaranteed to win you marks. Step 1. We assume the opposite. We say, all right, root 2 is rational, meaning it can be written as a over b, where a and b are coprime. Now, coprime just means they have no common factors other than 1. Step 2. We square both sides and rearrange things to get 2b squared equals a squared. Now, this means 2 divides a squared. Using our secret weapon, Theorem 1.2, this means 2 also divides a. Moving to step 3, since 2 divides a, we can write a as 2 times some integer c. We plug that back into our equation, and we end up with b squared equals 2c squared. What does this mean? It means 2 also divides b squared, which naturally means 2 divides b. And step 4, boom, the contradiction. We literally just proved that 2 divides both a and b. But wait, our initial assumption was that they were coprime and shared no common factors. The suspect's story has completely fallen apart. The assumption was false. Therefore, the square root of 2 absolutely must be irrational. And the great news is, once you master that, the variations are so much faster. Look at this one. Prove that 5 minus the square root of 3 is irrational. Again, assume it's equal to a rational fraction, a over b. Just rearrange the equation to isolate the root 3. So we get root 3 equals 5 minus a over b. Because 5, a, and b are all integers, that entire right side is a rational number. But we already know the left side, root 3, is irrational. There's no way an irrational number can equal a rational number. Contradiction. It's just an incredibly elegant and powerful way to prove absolute truth. Section 5, Chapter Summary and Exam Tips. Take a breath. You've made it through the absolute toughest logic in the chapter. Let's bring down the anxiety a bit and reinforce your newly acquired toolkit. Here is your ultimate revision checklist before test day. Make sure you can confidently draw prime factor trees. Remember the power rules. HCF is the smallest powers of shared primes. LCM is the highest powers of all primes. Memorize that golden formula relating HCF, LCM, and the two numbers. And finally, just practice the steps for proof by contradiction until it's second nature. Before we wrap up, I have one final giant common mistake warning for you. Examiners absolutely love to test this. The golden formula, HCF times LCM equals the product of the numbers, only, and I repeat, only works for two numbers. If an exam question gives you 3 integers, say A, B, and C, do not multiply their HCF and LCM and expect it to magically equal A times B times C. It does not work. You have to use the prime factorization method instead. To leave you with a really fascinating thought today, why do we actually care so much about prime numbers and unique factorizations? Well, because right now, the device you are watching this on uses prime numbers to secure everything. Modern digital encryption relies on the fact that multiplying two giant prime numbers together is easy, but taking the massive result and breaking it back down into its prime DNA, that is incredibly hard for hackers to do. The timeless truth of real numbers isn't just sitting in your textbook, it's actively protecting your digital world. Keep practicing, trust the logic, and you will absolutely ace this chapter. Thanks so much for joining me on this explainer.